multi-period problem for a stochastic demand. And the second part is a contract. Contract is one set of contract is for EOQ type contract. The second set of the contract is related to news vendor models. So today's I'm going to introduce one is a news supply model and a piece of the multi-period problem, and then I will show you how to get the result from news supply models by Mathematica. And you got to familiar with how to get the answers through today's assignments because of the next week. Okay, based on the news supply problem, the assignment will be related to the multi-period problem. Okay. So news supply model is a single period problem. Okay. Product has a little value at the end of period, and can make only one purchase. What kind of the product is feasible for news supply model? Newspaper, certainly, or the fashion apple, or any kind of product. For example, it's only available in 1 day, 1 week, 1 month, or 1 season, or 1 year. Okay, that's so-called the newspaper. So think about the smartphone. How about smartphone? Maybe 2 or 3 years. Okay, maybe 2 or 3 years. It depends. So in this model, we need to determine what is Q, single order quantity. So how much inventory we prepare for future demand, right? And since the demand has risk, so can be described as probability density function f of x and cumulative density function capital F of x. Yeah. And price certainly also influenced by demand. Okay, if the price is high, maybe demand is lower, or opposite. Or even the price is higher, the what? Demand is higher. It's also possible. Yeah, it's also possible. It depends on so this kind of model is also related to the marketing instrument in a way. Yeah. So in marketing research, a sort of news vendor model, also eligible. So we have the wholesaler price. What is wholesaler price? The cost for a vendor buy the product from an upstream supplier. So you will draw the picture for that. So we have vendor here. We have demand. It's a random variable x described by cumulative function and the density function. So the selling price. So the selling price is P. Selling price. And wholesaler price is buying things from an upstream supplier. Okay. So we certainly will have what? Selling price has to be larger than wholesale price. Otherwise, there's no need for discussion. Okay. So pi is what? Unit shortage cost for any unsatisfied demand. This unsatisfied demand. So we were suffering pi. Normally we use pi to indicate the shortage cost. Wholesale price is also traditional notations for wholesale price. So H, what is H? Is slightly different from EOQ model, but they still hold the same meaning of it. What is H? H in EOQ model is holding cost, right? So if for any things unsold at the end of the period, we have the holding cost, right? So you see for lot sizing problem, okay, we define what? Anything led to the next period suffering holding cost, right? Agree? Okay? Since all the demand can be satisfied and all the orders will arrive at the beginning of the period, okay? And anything left over to the next period would have the leftover cost, which is holding cost. So H is what? Whatever left. Most of the time we will use a triangle to indicate the inventory, so holding cost. The unit of holding cost for any residual items. But it's different from holding cost. It can be negative. What does that mean? For a positive number, that's indicate a cost, right? We need to pay some money to get rid of the leftover, because there's no value for future, okay? Or we can get some money back if H is what? Negative. Okay? For example, based on the newspaper, in MRP system, Taipei City, okay, we can buy a copy of the newspapers, the morning newspapers around 10 a.m. in MRT system for like $7.20. Normally the price is 10. What does that mean? For the vendors, actually they, okay, for newspaper, because of the purpose, the mirror of the newspaper, what is the maximum cost for a copy of newspaper? For the vendor, not for like China News, for example. What is the major cost for a copy of newspaper? One is what? How to get the news, right? The other one is how to edit the news into different pages, right? So then we need to what? Prepare the what? The motherboard for the newspaper, right? For example, if we print the full size of the paper for advertising, normally if we ask the print shop, okay, what is the economic scale for one copy? Actually, it's around like 1,000 copies. So if we ask them, how about we only buy 500 of it, they will say, well, for example, the 1,000 copy is 20,000 NT dollars. One copy is two NT dollars. So how about 500? Well, maybe 19,000. Yeah. The difference is what? Is the ink and the paper. That's all. Yeah. So the price per unit, the per unit price for a copy of the newspaper is very cheap. I mean the marginal cost. But the fixed cost for a newspaper normally is very, very high. Very high. Yeah. Now we have the so-called Liberty newspapers, right? 自由时报. Okay. Actually, for the sales volume, it's not. I mean, since we also have like maybe like 苹果日报 Apple newspaper. Okay. Apple newspaper used to be the what? Most popular. No, not the most popular one. Based on the sales volume, Apple newspaper was number one. But however, what is the most popular ones? Liberty paper. Because they what? They are the company not only sell the newspaper to consumer, also what? Deliver it free to consumers through like the gas station system and so on. Okay, try to expand their market share. Because of the marginal cost for a newspaper is extremely cheap. Okay, so they are the number one newspaper in Taiwan. Yeah, so that's also a kind of marketing strategy related to the products feasible for a news vendor. Okay, but no matter how, the whole wholesale price is larger than whatever we can get from the aftermarket. If the wholesale price is smaller than the aftermarket value, then we may what? Not go in to prepare the product for sale, right? Yeah. We prepare the product for what? For the demand in the aftermarket.
What's the meaning of demand? CDF? What's the CDF?
Since the mathematic is there. Here is an example. So, this example defines the probability density function is what? Exponential distribution. Okay. So what is exponential distribution? Okay. Yeah. You can see the formula for that. You see? This is the exponential distribution. PDF, right? So what is CDF? Okay. This is a cumulative density function. Okay. So this is the distribution for exponential distribution, and this is a cumulative density function for this function. I have sent out a document to you, right? So this is a cumulative density function. Probability density function. Okay. Any more questions? Okay. So now we have a situation to explain the cost parameters, how cost parameter affect the model. Okay. So purchasing cost, if we decided to buy Q, okay. So purchasing cost is wholesale price times Q. Okay. Then we will have a case. If we buy, so X represented the demand. So if we buy more than demand, okay, so we will suffer what? What residual cost, right? Since we buy more than demand. We buy more than demand. Okay? So we will pay for what? PX, since what? P is the selling price. We only sell what? X, right? Since we buy more than demand. The maximum units we can sell is the demand. Okay? Right? Then we have to suffer the residual cost. For how much? How much unit of the product? The difference between the what? Order quantity and demand, right? So on the other hand, if we buy higher than demand, okay? So which means demand is larger than what we have prepared. So how much we can get from demand? Selling price times the order quantity, right? Okay. Since we have some demand and satisfied, so we need to pay for the shortage cost for that. So the shortage cost is based on the difference between the order quantity and demand. I forgot to put this on. I believe you are sit far enough here. I tried the so-called medical mask. It's hard for me to take a breath here. You know, for the paper mask, it's okay. because it's very thin, right? But for this mask, but since is there anyone have the paper mask? Since I don't have the paper mask, so now I'm now going to what? To the Family Mart for shopping because of that, yeah. Medical mask. I cannot move for more than like 10 or 15 minutes, yeah. Okay. So the revenue here is strange. Maybe the notation is not consistent. Yeah. That's it. Okay. It's okay. So now we can check the expected revenue. Okay, for that. So we have two cases. Okay. So one, if we decided to buy Q, so we need to pay what? W times Q, right? That's the revenue. Okay. So then this term is what? This case, right? Demand is between 0 and Q. Demand is between 0 and Q. So this is demand what? Is larger than Q, right? So when the demand is between 0 and Q, so that's this case. Okay, we will get the revenue PX subtracted by the residual cost. Okay, so this is what? We will get the selling price P times Q subtracted by the what? Penalty for unsatisfied demand. Okay. So then we need to take the derivative for our revenue function. First derivative and second derivative of the revenue function. So through what? So this is the formula for the partial derivative. Because of we have the what? Variables on the what? On the upper and lower bound of the integer, right? So we need to, so this is so-called the deviation by parts. Okay, so this is the formula. Okay, let's check the formula. So G of X is the integrations from A of X through B of X over the function of G of xt. Okay. So then we take the first derivative. So actually is what? We take the derivative inside the integrations over the G of G functions with respect to the variable. Okay. Then plus the what? The upper bound of the integration. Okay, the first derivative of it, and then plug in the B of X into the T. Okay, so subtract by the G of the function for the upper lower bound. Okay, take the first derivative of the lower bound with respect to the variables. And by plugging the lower bound into the t, this is the formula. This is the formula. So then let's try. So let's take the partial derivative over the q. So this is minus w. Then take the derivative over the q inside this expression. So become what? Negative h, right? So over the q, this is 0, and this is 0. Q become to 1. So this is a negative h. Okay, then plus, take the derivative of this function become 1, right? By plugging the q into this function, q into this one, this become the pq minus h. Become q minus q, this is 0, right? So this become the what? PQ. And this one, put the q directly into the x. Okay. Then since the lower bound is what? 0, it disappears. Okay. So since for here, we'll take the derivative over the q for this function. So this become pi plus q plus pi, p plus pi. Okay, times the f of x, still for the integration. Then the upper limit, is not related to q, so it becomes 0. Okay, and then subtract by, we take the first derivative over the what? Over the q is 1, and then put the q into the expression. So p times q is only turn left, right? Times the f of q. Since you put the q into the whole thing here, so this is also replaced by q. Then, so this is minus h. So this is integration from 0 to q over the density function. So this becomes the cumulative function. Okay. So this is what? Becomes the what? 1 minus the cumulative function. Normally we will have a notation for that is for the f bar of q. So for second derivatives over the first derivative, easy. Okay, this disappear, and the first derivative of the cumulative function, then return to the density function. Okay, so we can get this expression because of the second order condition is negative. So by what? Setting the first order condition 0, we can get the what? Optimal order quantity. Okay, so this is the inverse function. Inverse function. What's the inverse function? So actually, f of q equal to what? With me? So see if W is less than minus H, what will happen? Based on the mass. So means what? F of Q larger than 1, right? That's impossible. Because of F of Q is a what? Cumulative density function. Right? F of Q is always what? Less than or equal to 1, right? Cumulative density function, CDF. So since f of q is increasing function in Q, right?